Welcome to Evolution in Controls, Morrell Group's new video and podcast series. We're glad you're joining us. For today's episode, we're going to take a look at some technology behind the biggest automotive paradigm shift since Henry Ford developed the modern-day assembly line. If you don't think that electric vehicles are set to fundamentally change our automotive industry, you need to better understand the facts. In 2020, nearly 1.8 million electric vehicles were registered, and that's nearly triple the number registered just 4 years earlier. And the pace continues to accelerate. In any understanding, the battery is the main component for the electric vehicle. We've had electric motors for 100 years, but it's only been recent innovations in battery technology that have allowed the batteries to charge, store, and recharge in the time, amount, and rate that makes electric vehicles a viable alternative to the internal combustion engine. But just how exactly are those batteries charged? How do the manufacturers know that the batteries will charge, recharge, and store the amount of energy needed? What process do the manufacturers employ to provide the quality and dependability that we've come to expect from our internal combustion cars? To answer this and other questions, let's meet Tony Little. Tony Little is Morrell Group's Senior Product Manager for Bosch Rexroth Electric Drives and Controls product line. Tony was responsible for leading Morrell's entry into the EV battery cycling and testing. Just last year, Morrell launched a battery cycling DC testing solution that's being used by component suppliers and integrators for the manufacturing in the EV market. Tony, thanks for joining us.
Thanks for having me, Tim.
So, talk to us a little bit about the solution, the battery cycling DC testing.
Sure. So Morrell's battery cycling and DC testing solution is kind of a product born out of necessity. It's one we're very excited about. So we took standard components from Rexroth,
Okay.
noticed a change in our customers' needs, and we were able to, with Rexroth, us being an engineering partner of theirs, we were able to design a system that could meet our customers' high voltage and high current DC testing needs for battery cycling, or eAxle testing, where we're doing battery simulation to some sort of inverter on the vehicle that drives the propulsion system on the vehicle, to do the validation in the R&D phase, and then get into the production phase, end of line testing, inline testing, various things of that nature.
So we're taking a standard Bosch Rexroth product or products. Are we modifying it? Are we just reapplying it in a different way?
No, yeah, absolutely not modifying it. Reapplying it in a different way would be the right way to describe that. So it stays within the scope of things that are already readily available worldwide. Rexroth is a global supplier, global support, and all the things that come with Rexroth products. We took the standard products, applied them in a different way. Instead of using them to be a motor inverter, we're using them as a DC inverter to push DC power out to the new EV elements that we are all experiencing nowadays.
Well, give me some details. Talk about the specs. Volts, current, power.
Sure. So the solution is a modular, scalable, and what I like to call future-proof design. And when we get the specs from a customer, that'll have what power levels we need to go to, what voltages we need to do. We'll sit down with that spec. We'll look at all the options we have with the various power stacks from Rexroth. And we take that modular concept and we design up a system. We can range anywhere from 20 volts DC up to 1100 volts DC.
Okay.
So we have a wide voltage range. And in that voltage range, we can hit up to 3 megawatts.
Wow.
So yeah, really big.
What kind of current is that?
Well, it depends on the cycle. A lot of times, if we're doing a battery, we'll be limiting the current and stuff like that. So a lot of things are running around in the mid 100 kilowatts right now. So they're getting around the 300 amp range. But there's need in eAxle and eMotor testing to get into the 1000 amp range. So we can go very, very high.
So let's talk about the eAxle for a second.
Sure.
Are we actually simulating a battery?
Absolutely.
We're not charging a battery.
No.
We're acting as the battery.
Yes. So to see what kind of performance you can actually get out of these eAxles and eMotors, you need to be able to push more power than some batteries can provide, just to see what their limits are and things like that. So that's where the battery simulation on an eAxle dyno or something like that comes into play.
And that's why you need the higher power. And
yes,
the higher
that's
current.
where we get. That's the applications we get into the real big power that are a lot of fun for us. But
so
yeah,
that's one way that it's being used. It's actually simulating a battery. How are the manufacturers using this in the manufacturing environment?
Sure. So our largest piece of success thus far has been in end-of-line testing for batteries. Like you'd mentioned, in 2020, we started to see the supplier network kind of show itself for what the EV market is going to be needing, right? We're starting to see the traditional powertrain customers getting into line building for batteries. And instead of farming out different pieces of that line, they're able to take this all underneath one umbrella. So we're starting to see tier ones grab more pieces of that line building instead of farming out cells to other companies that are specialties in different things. So it's pretty interesting to see that work kind of be localized. And we kind of took off with that with some of our key partners on the end of line test.
So what do these things look like? Are they the size of a refrigerator? Is it a standard panel? Is it a little box that would fit on the counter? Tell me about the design.
Sure. No, I'm glad you asked that. So in this space, there's a couple of other players. We differentiate ourselves by being able to fit a lot of power in a small package to a liquid-cooled drive package.
You're using water on an electric device.
We're using water on an electric device.
Great.
Yeah.
Is that exciting?
That is very exciting because it allows us to get the package. The drive itself is 2.5 times smaller than what it would be as an air-cooled drive. We have air-cooled options as well, but everything that we've done in this space has been liquid-cooled, and it's worked really well for us. We're able to fit a very high power density DC testing solution into a very small panel.
And that's important partly because it goes on the production line, right?
Absolutely.
Is it at the end of the line?
Yep, typically these are end-of-line tests. So our success has been in end-of-line test. Some of the other applicable areas would be inline testing of like modules or cells as they get into assembly. But our success thus far has been an end-of-line test. But the applications are continuing to show themselves to us as we venture further down this EV trail.
So who's setting the specifications? We're obviously building a product, applying Bosch Rexroth products to a new application.
Sure.
Who gives us the spec for constant voltage or the amount of current or the current ripple or
Sure.
Where do the specs come from?
Sure. So the specs have been, EV has been in the works for a long time. The end users who are putting out these EV products have been developing them.
Okay.
And in some cases, we've been involved in some of that spec development and talking about that, talking about what is attainable, what is realistic. And in the end user who has the need for a test to be performed gives us their spec. So we get the spec from the end user, we design our system to meet that customer's spec. And we help the test controller integrate to the test controller via whatever communication means they have. We have a very open platform, so we can integrate over almost any feasible modern day field bus or communication method. And we design a system that meets that specification, and then we help educate the test controller as well as the station controller, whether it be the OEM building the line. We can communicate to their PLC. We help them with every facet of integrating our technology to their system to make it very seamless for our customers. But we tell them, if you need to do constant voltage and vary your current at various levels, you'll put it in this operating mode and you'll operate just like this. So we are really a full high voltage solutions provider. We take it from, you give us the spec, we design your system, we get it built up, hot test it here, we integrate it with your OEM, and we really take it through to completion, really making us an engineering partner for not just the end user, but the OEMs that they select.
So in the last few years, we've seen huge development and a trend. Look forward. What's going to be like in 2 years, in 3 years, in 4 years? What's the product that we're supplying or the solution that we're supplying? What's it going to look like?
Honestly, so this is actually a pretty interesting topic. So we built a standard that's kind of been the go-to for our customers for the last 2.5 years.
Okay.
And with new products from Rexroth and evolutions in this market, we're starting to figure out a need to make it mobile or make it more modular to expand it easily in the future, because battery technology is only going to get greater as we electrify more equipment, maybe outside of the automotive space, but into the public transit space or the agricultural space. Bosch Rexroth's doing some very exciting things with off-road mobile electrification.
You mean like tractors?
Yes.
Okay.
Yep. Tractors, municipality vehicles. Lots of really cool high power stuff coming down the pipeline there. So we're seeing new products from Rexroth that are coming out and with their Control-X drive. That's an exciting product for us because it's going to allow us to shrink our package even more and reach more applications on what could feasibly be a mobile push cart that could test these things on a mobile basis.
So not going to be a refrigerator that's stationary in place at the end of the line.
It's quite possible, yeah. We're looking into all avenues here to meet our customers' needs. Like I said, in 2020, the the path forward for EV started to show itself a little bit more to the market and getting out of the R&D phase, as a lot of manufacturers are looking to roll their first EV trucks and that off the line. Some of the cars are already off the line. We're starting to kind of see the market take shape, and as it does, Morrell is well poised with our engineering resources to move with it and help our customers solve these problems of the future, and hopefully be a key part of this.
Tony, that's fascinating.
It is.
It sounds like the future is going to be rapidly changing, and sounds like you're helping to position them right at the forefront.
Absolutely. We're doing our best here at Morrell, and we're thankful to have the tools that we need to do this with our engineering partners at Rexroth, and the tools that we have here at Morrell, mainly people, to move with that fast-changing market.
Tony, thank you very much for taking the time to talk to us.
No, thanks for having me.